Oh, my mic was off for a second there. Hey. Oh, nothing is up. Nothing is up. My whiteboard's a blackboard. You know what? Let's do that. Wait, that'd be fun. Who says I have to make it, one color? That'd be fun. Let's do a chalkboard. Why not? Let me put this here. What week is it? I think it's week 5. I don't know. And this is that. Okay. Do the chalkboard first. Oh, how do we think? Is that like 2? Let me make it a little lighter. Yeah. Oh yeah. Oh my gosh, I feel like a real mathematician. Oh. There we go. My mic just cuts out, you know, it loves me so much. I'm just gonna grab this PDF to see what we have to do. I think we're gonna do a lot of them by definition first, so... Oh yeah. Sorry, I just got excited. Okay. Use your results. Sure. Sure. Oh. It's gonna be, I'll write it. I'll rewrite it. I'll rewrite the problem, actually. Okay, so we've got... Let me pull up a little white. How does that look? How do we like that? Yeah, that's pretty good. Okay, so we need the Laplace transform of e to the ibt. Oh my gosh, it's Scribble. Hey, how's it going? So this is going to equal the integral from 0 to infinity of e to the ibt times e to the negative st dt. It's going to equal... Honestly, these are... I don't want to say trivial. They're not entirely trivial, but like... Oh wait, I can't just say s. Can I? Wait. Okay, he doesn't say by definition. Hehe. Something other than pi? Blasphemy? Well, you'll see we use this to get that. I'm trying to think. Does he want us to do... So, if I factor this out, this will be s plus... actually, s minus I b t dt. I think he probably wants us to do it by definition. So we just have to integrate this once. It's going to equal... Why is my brain not working? E to the negative... Actually, it would give us e to the x. And then, if it's e to the negative x, then that would give us negative e to the negative x? Yeah. So negative e to the negative s minus I b t dt, or not dt, from 0 to infinity. Okay, so this is going to equal 0 minus, and then when t is 0, wait, okay, what am I doing wrong? What am I doing wrong here? This is not a hard integral. It's really hard to talk because I don't know anything about the subject. Okay, wait, I can explain it a little bit. So, okay, the motivation for this is this. So when we have a differential equation, and a differential equation is just some equation that has derivatives in it. Let's say it's like something like this. I'm gonna have to clip this. So we have a differential equation. It's got some derivatives in it, which just means that these are like the rates of change. So we could think about this, if we want to think about this in an applied way, like this would be position, this would be velocity, and this would be acceleration. So this is how much the position is changing, this is how much the velocity is changing, right? So we want to solve this. because we have these kind of equations in our world to model different things, and we go, okay, how do we solve this? This is kind of weird. And you learn when you take an introductory differential equations class that for the function e to the x, its derivative is e to the x. And so because it has this sort of cyclic derivative, there are other functions too that have those, right? Sine and cosine. When we take their derivatives, we get sine, cos, sine. Obviously, the signs change, but these signs as in the positive and negative, not the signs themselves. But because of the cyclic nature, we can say like, oh, y is going to equal e to the x. Then we can possibly solve these equations. And so that's how you solve differential equations initially. Now, what we do as we get up a little bit in differential equations is we say, okay, well, instead of saying e to the x, let's say that there's a generic polynomial that our function is going to be. It's going to be a constant plus a constant times x plus a constant times x squared plus a constant times x cubed, and so on. And so because we want this polynomial to go on forever, we can write that as a sum. So we have some term that defines these coefficients, right? This will be like a function essentially that we plug in a number for, and we say that this is an infinite series. So this is like n equals 0 to infinity. So we're saying like, okay, so for n equals 1, we get, for a1 equals a, a2 equals b, a3 equals c, and we get this approximation of a function that we can use to solve this. And if we were to, this is kind of like saying like, oh, what is our e to the x? Right, so we've instead of saying, okay, we're going to put e to the x in for y, we're going to put this in for y. Yeah? Because it's this generic function, and a function like this can represent pretty much any function. Because if you think about it, like when we add, if we're trying to like curve fit some data to fit through a bunch of points, we can just like keep adding, you know, x squareds and say this is an x to the 9th polynomial or something until it gets through all those points. And so the Laplace transform is sort of born from the fact that we say, well, we have a sum that goes like n equals 1, n equals 2, n equals 3, right? But like, what if we wanted to figure out, well, what n was at 0.5? We can't really do that, right? Like in our sum, the way we defined it was we said we have to add up these integers and we plug these integers in. So we need a sum that is continuous instead of that. And so we come to the conclusion that we need to use an integral of some kind, because we're adding up infinitesimally small pieces to create the y instead of a sum. And so that integral turns out to be some function times e to the negative st dt. And by using this, we can turn differential equations, which we would need to do calculus and do all this other stuff for, into just algebra. And you can just solve it by algebra. And there you go. You only know algebra, and you can solve differential equations now. So that's what the Laplace transform is sort of existing for. I don't know. I'm not doing it right now. It's not correct. Curve fit. Oh no, the trauma. Yeah, I also have trauma from curve fitting. I didn't get any of that. I'm sorry. Oh, it's fine. I know you probably don't know about like. Have you guys done like function stuff yet? I know your school is pretty ass at teaching math, from what I know. Damie! Hi, Clem! Oh my gosh. How are you doing? Teehee. I just finished explaining what the Laplace transform is, so I can't... Oh my gosh, drown in Friday. Wait, it is Friday! Oh god, oh no. Oh no. Oh my god. Oh my god, I need to, oh my god, Rev is here too. I need to have like, okay, when I redo, because I'm thinking about using Warudo for my stream stuff, so that I can have like a reactive environment, so I can just have the weather update to my local weather and like the time change and stuff. I will make Drown Him Friday like drop an actual bucket of water on me, so that when you do that, when you put a bunch of them, it'll just be like a flood. Oh my god, that's so many Drown Him Fridays. I'm sipping so hard. That was a good sip. He did this problem. It's definitely not -1. Me when I can't do an integral. Guys, I swear I'm an engineer. I swear I'm like good at math. I can solve differential equations. Where did he do this? He did it and I wrote it down. I was like, that's so easy. Why do I need to worry about that? Oh. Oh, he just... Sorry, what was I saying? Oh yeah, your school. Well, okay, if you ever want me to explain something, if you're like, hey, here's a thing I don't know, teach it to me, I will do that. Even if it is fractions. I don't know if I could teach fractions. I'm of the opinion that like the more basic the math is, the harder it is to teach. Calculus, easy to teach. You're like, hey, you're basically just adding up stuff, or you're saying how much does stuff change. That's basically all calculus is. But my god, we must go, sir. I'm at you're oh my god, a crossover in real life? No way. That's crazy. Have fun. Damn it, we gotta do a meetup one day. We gotta do a Starfy convention. That'd be sick as fuck. Lego bricks put together. Lego bricks themselves, the entire design. Oh yeah, for teaching math? Yeah, exactly. It's like, how, like, if you know what Lego bricks are, you can build stuff. But trying to explain what a Lego brick is, that's hard. That's hard. This equals, I guess I should probably actually do this. Okay, so this would be -e. How do we prove, okay, let me not be dumb. How do we prove e to the, sorry, Laplace of, what even is this? Laplace of e to the st? Wait, Laplace of 1. Wait. How did I prove? Why am I like tripping right now? I know basic ass math, maybe algebra, mostly geometry, and whatever I didn't forget about trig. Those are some of the most important skills to have, is the thing. Honestly, most of, okay. You would be, so for practical applications, you would be surprised at how much algebra there is. It's mostly algebra, actually. There is not a lot of calculus. Even in, like, fluid dynamics, yeah, we're doing some calculus, but, like, you can kind of avoid the calculus if you know about what the calculus means, because, obviously, if you don't know calculus, what it's going to do is it's going to limit the geometries you can work with. So, for example, I can ask you a question about, like, what the area of a triangle is. Right? You know how to like find the area of a triangle. Like we can prove this in geometry, or the area of a square or something, or the area of a circle. But if I ask you what the area of this function, like x to the 5th minus x to the 4x cubed plus 3 over this section, you wouldn't be able to solve that, right? That's a different area question, different geometry. That this is not what that function looks like, but you know, that's kind of what calculus does. So you can still, like, I could give you a fluid dynamics problem if you only knew, well, you need to know physics, but I could give you like a static fluid dynamics problem and be like, hey, what's the pressure, or here's a, Great one. Here's a concrete wall. At what point will this concrete wall accelerate if there's this much water pushing on it here? This is a great question. Submerged surface. It'll be a non-uniform pressure distribution, but that pressure distribution rate is like just basic shapes. I mean, my dad had the circumference of a pipe and not the radius because he couldn't measure it. And then I immediately thought, wait a second, you can fit 2 pi radians in the circumference of a circle. So like if I divided by approximation of tau, then I can get the radius. Exactly, exactly. That's why math is useful. There's a lot of reasons why math is useful, especially if you're working with things that are made. I mean, if you're trying to make things, you have to use math. Like, even if it's just woodworking, right? Like, also curve fitting. Yeah, curve fitting is, oh, data stuff. There's a lot of cool stuff you can do with data stuff. It's negative E. It's the negative, okay, what does this mean? That means it's 1 over e to the s minus ib t. Just get a toddler to draw a curve between the points. Well, the least squares method, so it's a method for approximation, which is, in statistics, you can just, one of the things that we talked about in my data analysis class, if you have a bunch of data, you can literally get a curve that exactly goes through all of those data points, right? Like if you wanted to. Something squares? Nah, just a random ass line. You can basically make the equivalent of a random ass line because what you're telling this curve is, I want the distance between this curve and the point, every point, to be 0, right? And you get an r squared value of like 1. It's supposedly like perfect or whatever. But you don't actually want to do that a lot of the time because it's not telling you a real trend. It doesn't actually exist. Why am I like tripping the hell out on doing this one integral? I just need to do e to the at, bro. Okay, so yeah, it's 1, so it'll be 1 over, when we integrate, 1 over, I guess, negative. Do I want to keep the negative like that? No, I'm gonna leave the negative. We'll leave it as s minus a. So this will be ib minus s t. So we have 1 over ib minus s times e to the ib minus s t from 0 to infinity. I needed a wiggly boy to curve, splines or whatever. Bane of my existence? Wait, when did you... What wiggly boy did you need to curve? B minus S. Oh, because we get a negative. Yeah. Okay, we're winning. I can integrate, guys. This isn't even the integration by parts. This is a regular ass integral. It's been so long. It's been so long. Wait, but when t equals 0... Oh, I just get 1. I'm actually so goofy. 1 over s minus ib. Jesus Christ. Monsi. It's a funny glyph? Ooh, wait, let me, okay. I'm gonna multiply this by, it's a complex conjugate. S plus ib. S plus ib. And that gives us s plus ib over s squared plus b squared. And so cosine of, I guess, of bt, and this is based off of the e to the I pi equals cos, well, e to the I theta, cos theta plus I sine theta. So what we're saying is instead of theta, it's b. So we just have we're trying to get to cos theta plus I sine theta. So our cos theta is this part, because that's the real part. So s over s squared plus b squared, and sine bt equals b over s squared plus b squared, which is nice. Glyph or polka? Wait, let me see. Oh, that's the name of the thing. I see. I see. Yeah, see? Yeah. How about the Drown of Friday is still going on? Monsi or polka? What is what? Monsi. Back, behind, rear. Oh, my ass. Oh, it's a different language. This is so interesting. Oh, it's telling me one of my extensions is updated. On the right is the glyph. Oh, I see. You're trying to draw it. Wait, neither one of these are wiggly. All of them are all of them are straight. Or at least the ones that I'm looking at. Maybe I'm looking at the wrong thing. Did my music pause? Maybe, perchance. Oh, it just ended. That's awesome. Oh, this one. I saw a Monsi bin drawn. Let me see. Maybe I'm just looking. My eyes are not great. I feel like we've established this. When I love when I get on stream because you just get so, like, streamer brain is such a thing. Mandarin Tongzhi. This is Tonsi. I love that in Mandarin, you call like gay people comrades. Like, yeah, Tongzhi. My favorite thing. Okay, I don't need this actually. Get out of here. Deleted. This is problem 1. I don't know, we might actually be able to finish this, except that I took 23 minutes doing that, which I really didn't need to do, but it's fine. We're gonna do the Laplace transform of t to the -1/2. Integration by parts. Yippee! Okay, it's kind of not. He says it's not straightforward. I can see why it's not straightforward. Is that Isan? PLA? This is one of the places I buy filament from. Okay, Laplace. I love how, like, fancy the Laplace is. Or, we draw it. He's like, I'm gonna draw it really fancy because I never get to draw fancy stuff. Like, you can just do this. Who wants to do that? Okay, this is equal to the integral from 0 to infinity of t to the -1/2 e to the negative st dt. Okay, integration by parts. So the thing is, if we take down forever, it's gonna be recursive. We want to go up. Okay, I just said a lot of things. I don't actually know. My mic demon has evolved. I don't really know how. Exorcism when? This summer. what I think I'm gonna do is I'm gonna wipe all my audio drivers and see if that does it. And also like wipe my OBS and see if that does it. And like reinstall everything. And probably also uninstall the software for the microphone I have. The thing is like it works on my PC. It doesn't work on my computer. I know, yeah, just if I get rid of all of the drivers, then it won't work, and then it won't blow up, obviously. Okay, it doesn't really matter what we do to e to the negative st. We could integrate it or take the derivative of it, but how are we going to get rid of this t? What I was thinking was we do t over here, so we can get it to do this. We can say... If you somehow unplugged it, I bet it would still do it. Low-key, yeah, I don't know, man. It's the positive 1/2. When we take the positive 1/2, we have to say we multiply by 2. So this is going to give us, like, something that's kind of similar to that. Like, we have a 1/2 and a 1/2. This is just 1 over... But with integration by parts in the recursive way, you need to be able to say they're exactly the same thing. It's not like I can just say... It's not like I can flip it. Like, if I flipped it, then I would have to flip everything. Let me see. Oh, wait. Never mind, he told me how to do it. I'm not even just... Okay. Set up the integral that represents this transform and make the change of variable substitution t equals x squared over 2. Okay. I was just like going for it. I want to see if I can do the question on the funny website. What's the funny website question? X squared over 2. Okay. It's so funny. Okay, so we get x squared to the minus 1/2 over 2. E to the negative s. Uh-oh. Okay, s x squared over 2. D x squared over 2. Not really sure what that means there. Ooh! Sorry, I'm squishing myself. Okay, what is this? The funny question. Oh, this one... Why is there a password? It just says good luck. What the heck? I like how it's like in the background it's asking for a password. I don't know if I could do this. Given set a equals 1 through 13, find a permutation p that applies for... I feel like you could do that. Find the password. Oh, you have to I can't see the thing that's asking. Fine, I'll view page source. Okay, wrong password. Password. Epress function e if e dot which equals 13. Is it 13? No, it didn't do anything. That's how you solve the problem, actually. A load page password.val. Wait, are the passwords stored somewhere else? I can't even read it. You can't. Pro tip. It isn't stored. Oh, well. Okay, I give up then. Normally I don't give up that fast. Okay, but if they're asking me to solve a problem and I need a password to find the problem to solve, I feel like that's a little recursive, isn't it? Okay. So we have our t. We like that. I love t. No, the answer is the problem. The answer to the problem is the solution. Well, yeah, but I can't read the problem. Okay, so we said we did that. Set up the integral that... Oh, I did that. Use the above result to determine an expression for that as the product of two integrals. What? What? Okay. Oh, determine it. Okay. Determine an expression for L of t squared. Don't use the same variable x. Then rewrite this expression as one double integral? What? Wait, this is crazy. There's no way I was gonna be able to do this. Wait, what? Okay, first off, I have to figure out this. Okay, if t, this is not correct. Okay, so if t equals x squared over 2, then dt equals 2x over 2 dx. So this equals x dx. Okay. So then dt equals, yeah, x dx. So x times x dx. I have to, okay, so I have to square this and use two different, what the, you can't multiply integrals though, what? Sounds like the Pikuniku OST? I've never heard of that game. Okay, if I just like square it, we can say x squared, okay wait, x squared to the negative 1/2 is gonna be 1 over 2x e to the negative sx squared over 2 times x dx times engineers when they have to do actual math. Actually 1 over 2y e to the negative sy squared. I'm just doing what he told me to do, which is just change it for y. How do I turn it into a double integral? Mildly anywhere that's the clear image. Oh, we could at the end how do I rewrite the expression as one double integral? I've never done that before. To be fair, no, I took Calc 4 here. We never really did that. Like, the product of two integrals is not the integral of the products. That's not how a linear expression works. Sorry, linear operator. Turn multiplied integrals into double integral? I've never heard of this happening before. Turning a single integral into a double integral. No. Did I get AI to do it? Oh, writing a model to make AI do it is going to be way harder than just solving it. But we can do it in MATLAB or something. Like, okay. How long does it take to do like one calculation? How long does it take a computer, I used to know this, to multiply two numbers? In my an algorithm course. How fast can computer add two numbers? Okay, sure. 1 to 4 clock cycles. Okay, it's a nanosecond. This question is asking about a permutation, right? Take a look. Find permutation that concatenate, turn them all into double-digit numbers. Okay, it's only like 13, and it's a permutation, not a combination, so I mean, realistically, that's what, like 13 to the 13th, if it was a combination. But it's not that, it's 13 times 13, right? So it's a permutation. 169, that's like 169 nanoseconds. It's like, it's not gonna be computationally intensive enough that we can't just write an algorithm to loop through it. So we'll do that. I bet we can do it. We just have to set it up right. It's just gonna be like we have to turn the math language into computer language. I don't know how to do this, so let's just do some regular ass Laplace transforms that are easier to do. I say easier, but I couldn't do them. Okay, I haven't done integrals in a long time, guys. Please. Please be kind to me. I'm better at doing, like... okay, t squared e to the negative 3t. That's gonna be a... Well, I know what it should be, which is, like, nice. Okay. A. F of t... Or I'll find the Laplace transform of t squared e to the negative 3t. Okay. What if I knew how to read math language? Oh yeah, well we can go over that too. It's not that bad once you know certain... There's not that many complex... Like, I know all the symbols in that, and I don't know a lot of proof language, so... Alright, no pain, no gain, let's go for it. T squared e to the negative 3t times e to the negative st. Also, I don't really find these... I find these kind of zen. I don't think they're particularly, like... My professor's like, okay, so who wants to do t squared cosine 2t? Nobody wants to do that, right? And I'm like, really? That's not that bad, guys. Like, negative s, or negative 3 minus s for t. No point to really doing it without a negative there. The only symbol I don't know is the funny thing. Oh, that one? I think that's approximately equals. Let's see. Equals sign with squiggle over it. Oh, congruent. Exactly equal. Sure. Summation. Yeah, summation is just, well, we just need to add that. That's fine. So what it's saying is that for every... what is upside down A? For every, okay, so for every 0 through 12, our sum from the beginning to the end of P, that's a permutation. Permutation times 14 to the, I guess that would, is that times or cross? We have to say that the permutation, I'm guessing times. Exact opposite? Okay, well, gosh. I know, there's no really like, well, I guess, okay, it's not that. Approximately equals is this thing. It's two squigglies, not equals squiggly. But yeah, we'll just say that, well, I don't know, we'll just, basically what I would do is just say, okay, here's our thing. Here's all of the permutations of it. Let's just run through every permutation and check which one works. There's only so many permutations. If it was combinations, we would be kind of, boned. I have to remember how to define a permutation, though. Set theory or whatever? Yeah, I don't do that. I'm an engineer. I wish I did. Gotta ask Storm about that, or, and Stucky. They probably know way more than I do. Okay, if it's negative 3 to the negative s, we're flipping powers of t. Or flipping signs. Thinking of doing engineering in college? Oh yeah! I would say, yeah, it's a really great, it's a great degree to have. I like it because, like, it just gives you a lot of freedom. So, plus, minus, plus, I need one more. 1 over negative 3, negative s, cubed, e to the negative. This, and then that's 0. Maybe a change of pace from fractions, I'm still annoyed on that. Well, I'm so real, like, I'm so serious, like, if you were interested in having, like, a mentor or something, like, and you wanted to do it based off of your own resources, or you wanted me to, like, help you out with stuff, like, I would be so down, because I don't, I think you're clearly, like, motivated to learn stuff, and I hate seeing people who are actually, like, really invested and interested just getting, like, you know, screwed over by Bad school systems. Yeah, you're 9th grade? Oh my god. Well, have you done any algebra at all? At least? Or not really? No? Oh no. Oh no. That's so rough. Oh my god. It's just really, like, okay, the thing is, like, it's not that you can't do engineering stuff. Because you definitely can. It's just that, like, when you are screwed over so hard like that, even, well, I guess it depends on where you're in school, first off. But, like, even in college, like, if you have trouble, like, doing, like, a calculus course or something, and you just get off track, it just becomes exponentially harder to do it in, like, the same amount of time that other people are doing it. Most I got is maybe simple geometry. Have you done stuff where it's like, okay, like, this is what a variable is, like, 1 potato plus 1 potato equals 2 potatoes, that kind of stuff? And then saying, like, okay, so if we're trying to solve for a number x, and then if we have, like, 2 of that number, and it equals, you know, 3 or whatever, then what does x equal? No mention of any algebra? Oh, I don't know if I could teach algebra. There's so much stuff you learn in algebra. Like, you do... When did I even take that? I was doing, like... A lot of it was, like, word problems. But... You know some algebra? Okay. But, like, you learn about lines, too. Like, the equation of a line, like, y equals mx plus b. Linear equations and whatnot. Okay, that's good. Slope, you know that? Okay, that's good. Hey, slope is all calculus is. But, like, so, like, for example, like, all the stuff I'm doing right now... Add. I'll wait. Zero to infinity, baby. 0. Love having a 0. Wait, when t is... Oh, infinity, yeah. Is that right? Back. I was gonna say, like, all the stuff that I'm doing now, you know, comes from knowing algebra. So it's like, so when I was in, I had kind of like this. So, like, when I was in 5th grade, that was like the end of my elementary. We did like basic algebra, so that was algebra. And then in 6th grade, I had like an algebra class again, and that was like lines and like probability and, you know, like quadratic equations, I think, as well. Never mind, it's back. Thank you, Khan Academy. Oh yeah. 7th grade, I had this class that was like number theory, but it was like kind of just algebra, but we also learned a bunch of other weird stuff. Then 8th grade, I had like my actual geometry course, which is like trig and like proofs. And then 9th was pre-calc. No, it was algebra 2, which was like, that was like this stuff. That was like, okay, we're gonna teach you like what a logarithm is. We're gonna teach you like about powers and exponentials and kind of extra trig stuff, I think. God, it's so hard to remember. And then 10th I had pre-calc, and then 11th was BC calc, and then 12th was my linear alg, and diff EQ. But we didn't do as much diff EQ. You know, some algebra 1 and trig. Honestly, knowing trig, dude, there are people who I know who are in this degree who don't know trig very well. if you can work with, the whole thing is like, okay, if you can take a vector is just, it's a type of thing that exists. It's like a construct, and we give it a magnitude, right? So it has a length, and it has a direction, so somewhere that it points. It's like an arrow, right? But it can locate points, right? So if we say like this point is, you know, 1, so let's say it's 1, 1, we can say like, okay, what's the length from 1, 1 to 0, 0? And then we've created a vector because we're like pointing to that point. And say, oh, we have to go, you know, up 1, over 1 to get to there. And then like we could say like, oh, what's this angle? Because we know trigonometry. And the thing about vectors is when you're trying to add vectors, you're trying to like say like, okay, if we have this arrow pointing this way and this arrow pointing this way, what's this arrow pointing this way, right? Like, and you know, there are questions that we can, there are ways that we can use geometry to prove that, but it comes from knowing how to say like, okay, I know that this length right here, this length right here, this is L, this length is going to be L sine theta, and this length is going to be L cosine theta. And those are like the one like most important way to think about it, because when you start like, maybe you're doing physics or something and you're doing, okay, here's my coordinate system, it looks like this. I know this angle, and I have a weight force going down. And you're trying to break that weight force into a component going this way, and a component going this way. You need to be able to say like, okay, well, I know this angle is here. This is theta. And so what's this? Oh, well, if we turn it, and we look at it like this is L sine theta. This is L cosine theta. And that's like the most important like trig you'll ever learn to use. And there are still people who don't, who weren't really taught to think about it that way, and it was it's not good. Now, why is this t not becoming negative is my question here. Oh, because s is great. Okay, yeah, s is great. S has to be greater than 3? No. Less than 3. Wait. No. Greater than 3, it's minus s. Yo, Damie, I'm at the hotel for Miku Expo? Oh my gosh, that's awesome. Dude, that's so cool. That's so sick. Can you say hi to Miku for me? Yippee! Yeah, so s is greater than 3. Okay, so that means that when we plug in t is infinity, it's gonna be a negative number, so it's gonna converge. Ooey ooey. Miku. Ooh. And then we plug in 0. 1. 0, 0. 2 over negative 3 minus s cubed equals a positive, right? Oh, I get why I asked him this in lecture. I said, okay, because we did this when it was s to the 4th, because we did t cubed here instead of t squared, and I said, oh, if it's t to the 4th, if you shift it, or if it's, yeah, like t 4th or t squared or something, if you shift it, how does it become positive? But I think it becomes positive because it's like, when we did in class, I think there was an extra negative there on that too. Let me see. Sorry, this is straight up just algebra. Well, okay, no, it's not algebra, it's Calc 1. Nope, that's an IVP. I don't know why I was looking at that for so long. There's pages that I skipped, I love. Yeah, so, okay, yeah, because I get it. We flip back and forth on the minuses, and then when we pull a minus out of the cubed, then it becomes a positive. equals 2 over s minus 3 cubed. Nice. I like that. I hope we get to do a... Is there one that's... Ooh, there's a piecewise function. Ooh, exciting. Okay, he wants us to do them all by... Okay, I see how it can get a little bit... Oh shoot, I need to find the Laplace transform first. A little bit arduous if we have to actually go through and do all of these by definition. Love you, Damie. Aw, thank you, Umbra. Love you too. I'm just in a good mood. I don't know, it's so nice just like going to math and being like, let me just immerse myself in a problem that like I don't need to think about at all. That math is so zen, and like you just step back and you're like, oh, no one's asking me to write a list of assumptions about whether the fluid is incompressible or not. I don't have to pick a control volume. I don't even have to do a conservation of mass. I just have to go, Laplace transform is an integral from 0 to infinity of f of t times e to the negative st dt. And then you just, it's beautiful. Now I know that sounds like maybe the most insane thing I've ever said. You know, it's just that, but I don't know, it's very zen. It's like throwing stones into a river. We get to do cosine! Oh my gosh! Poggers! I don't know, I just really like recursive integration by parts because whenever I do it and I remember how to do it, it makes me feel really cool. Makes me feel really cool. Teehee. Okay, this one, can I do it in my head? Oh, let me pull out the 2. I want to prove it by just saying it so badly, but it's not a proof if I just say it. Alright, let's do it over here. So we got t cubed, we got 3t squared, 6t, 6, 0. E to the negative 3t, and we get negative. I was going back and forth, right? Yeah. 1/3 e to the t. 1/9 e to the negative 3t. Don't look at me. I really need to find a Pikmin soundtrack to put in this playlist that's not like a mouse squeaking into my ear because it's so quiet. Hey, does anybody know what 3 to the 4th is? I don't. We're gonna write it as 3 to the 4th. That goes over and it's 0. Alright, well, do I have enough space on this paper? Yeah, I got space. I'm rolling up my sleeves. Okay. This is, I think integration by parts is one of the best ways to just be like, do you know how to integrate? Do it a lot right now. It's like that one, kind of want to do some maths, but I don't know what to do. Let me think. What would be a good thing? Like a subject or like a problem specifically? Because I could probably give you a problem to do. Okay, so 2 times e to the negative 3t. Just anything, really. Let me take a little look-see. I feel like... Okay, you definitely would need to learn Algebra 2 before you start doing pre-calc. Let me see. The great thing about learning algebra, though, is there's a lot. My brain needs activation, yeah. Whoa, what? That's so funny. Sorry, I was just looking for algebra stuff. Okay, integrated math, algebra basics, no. College algebra, what is that? Ooh, maybe you could try this. Ooh, wait, this might be kind of cute, kind of awesome. Maybe try this out. Maybe try out Maybe try, I don't like, wait, try, maybe see, oh wait, no, you know what you can do? Oh, is there an initial testing out thing? Oh, start, yes, here you go. Oh yeah, try this. That's some good, what is it called? Stimulation. What's the color code in the hex for your background color and your drawing color? Okay, that's a great question. My background color, let's see. My drawing color is... How do I get that in clip? Where is it? Okay, the hex is D8, D8, D8. That's for the white. And then, so, okay. Here, we'll put it up here. D8, D8, big D's, D8. I can't remember if hex is just a gray. Yeah, and then the background color is just a black. Okay, it doesn't want to give me the color, thank you. Does it want to let me know? Okay, 2F, 2F, 2F. I started writing in black. I just kind of ball out with whatever I feel like is fun though. Yeah. Although it's kind of fun to do math on a blackboard. I like it. Also, I'm not flashbanging you guys with with white backgrounds. Sometimes I feel like I'm like, dude, just look at white. And it's like, whoa, okay, whoa. It's a little too white right now. They're all gonna go to 0. Can I just like skip it? Okay, what if I just put in the limit and we just say, it's a limit. I did this one. Okay, let's put in the limit. Let's just do the limit. He's gonna be like, oh, you skipped it. I'm not gonna give you points, my grader. Okay, so it's gonna be -6 minus 6 over 1/3, 3 to the 4th. Where's my s? Wait, what? Wait, what? Why is there no s right now? What's happening? It should be... Wait, this is t cubed getting shifted. Oh, because I didn't multiply by s. It's just -3 minus s. Whoops, that's on me. Okay, so it's -3 minus s to the 4th. Okay, so that's equals 2 or 12 over, I guess, s minus 3 to the 4th. Which we could have just said, okay, yippee, we know what a Laplace shift is, and then we could have done it, but no, it's okay. 4 times... Oh, cosine is going to be a little funky, but we're going to do it. Just trying to think about where I have the space to do this. I could do it here. Okay, it's actually just e... Wait, this isn't an integral that I need to do by parts. It's just e to the... It's e to the... This is 2 minus s. So we say e 1/2 minus s. E to the 2 minus st. Negative? I think it's negative. Is it negative? Let me think. Let me think in my infinite wisdom. I don't think it's negative. Why would it not be negative though? Should it be negative? Chain rule. 2 minus s, -1. Should be negative, I think. Oh, because we're gonna flip the... Yeah. Lol. I'm just gonna say this. Say 0 minus... Wait, oh shit. I'll leave it like this. from 0 to infinity, just so he's not grading this. I don't know why I keep saying he. It's like the grader's doing this. I don't know who the grader for this class is. Okay, this is the fun one. Ooh, oh, yes, 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 yes. Sorry, I got too excited. Okay, cosine t, e to the negative st. Yes, 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 yes. Everybody go, yes. Okay, so fun. I say this like I didn't just like remember how to do this. And by remember, I mean ask my brother who's good at math and also look this up. So we want to... Essentially, these functions are both recursive, right? With this one, we get to go down to 0. Everybody's happy. Everybody loves life. This one, we're going to run around in circles around a pole, like the Pink Panther, where he's trying to paint the pole pink, and then other guys painting the pole blue, and they're just having the worst day of their lives. We don't want to do that. We're just going to be integrating and differentiating. And we have to be smart. We have to say, okay, when we do this, we're going to get... Well, we have to do some. So this is going to be negative 1 over s. I really should change that. 1 over s e to the st. Say 1 over s squared e to the negative st. Now we're going to pause. We're going to say, okay, so when we get this multiplied by this. We get this multiplied by this. And so we've gotten cosine, we've gotten sine. And then if we close it, so when we want to get off the train of integration by parts, we go over, right? So like we could do that until we get to 0, or we could do that whenever we want. We can just get off the train. But we have to have that be an integral, right? And so best viewers on streamboo.com. Yeah, I'm sure the viewers really want to everybody wants to hear about my awesome train analogy for the integration by parts. Don't even worry about it, bot. I'm only gonna be teaching robots. In 2025, Damie's stream all converted to robots, nothing else. I'd fuck with it. Robots gotta learn math too. Dude, teaching an AI math would be so hard. Oh, it'd be so hard. Okay, but yeah, so when we want to get off this integration train, we gotta make another integral. So what we'll do... I don't know if I want to do this here. I don't know if I have enough space to do this, really. I guess I could just scooch this up a little bit and then I'll have enough space. Alright. So, we're gonna say plus... It's multiplied by nothing, which is great. We love that. So we're gonna say cosine... Oh, actually... We need to have an intermission, actually, to do this, because we can't just prove it in one line. This has to be an intermission. Let me also do like a delineation that's large for the grader's sake. This is the intermission. This is where everybody goes to get some popcorn. Okay, so what we're gonna say is this. We're gonna say cosine of t times e to the negative st dt equals, because we're doing the integration by parts, so we can say that it equals this. It should equal this. Negative 1 over s. Okay, so we got that one. That times that. And then we have positive sine 1 over s squared. Sine t e to the negative st. And then we want to say minus the integral of like uv minus v du, so minus the integral of cosine t 1 over s squared e to the negative st dt. And if we pull out the 1 over s squared, this equals that. We can solve this equation for what cosine equals, and it's going to be that divided by 2. Well, not exactly. It's going to be like divided by 1 over s squared or something. Let me pull this down a little more. Oh shit, I circled this before I... Fine. I'm just gonna pull out the 1 over s squared now, actually. Because, s is just a thing. I don't really know how to describe s. S is like... What is s? S is... It's sort of like a placeholder variable that we use to transition between functions, I guess, is the best way to put it. Sorry, like intermediary variable. Sort of like how n, I think, sort of how n is an intermediary variable. That's probably a bad explanation, actually. Don't listen to me. Why did I say 0 to 0? 0 to infinity. 0 to 0 is just 0. Okay, so we have 2 cosine t e to the negative t dt equals, so negative 1 over, it's not 2, I lied. It'd be 1 plus 1 over s squared. Which is just kind of dumb if you think about it. Sorry, it's not dumb, okay? These guys are beautiful. And then we put a happy face because we've done the recursive integration by parts. Have I done it correctly? Maybe. Probably close to right, if not. Okay, so now we just, like, we divide this over, right? So it's gonna be... I'm feeling when I had the right idea, but I just did the math wrong? Exactly. But here's the thing that the big school doesn't want you to know. They don't want you to know that thinking the right thing but getting the wrong answer is actually better than getting the right answer but thinking the wrong thing. It does not matter if you can calculate things. There are people who are good at calculating things. There are also machines that are good at calculating things. If you're a person who can't calculate stuff well, that is so okay. I mess up calculations like every single time because that's what happens when you are a streamer, but also when you are a person who exists in the world, and it's okay. Generally, like, for example, if you're thinking about going into engineering, you would have reviews of your work. Well, first off, you would use like MATLAB programs that you set the equations up into, and then you say, evaluate for this for me, please, and then they evaluate it. But also, you have other people check your work. Like, got the points of the parabola flipped? Which ones? That's dumb. Oh, like the if it's concave up or concave down, the vertex? It's more just like it's not exactly a like a perfect, like, do you know this? It's more just like kind of where you might, because like if you want to learn algebra, I think that is probably going to be the most effective course they have that isn't like, and also probably one of the more useful ones that would get you ready for like, so I don't know this one like personally very well, and I think it's a newer one, but looking at it, it's like you get to do complex numbers, you get to do like doing complex numbers in algebras is really great. You get to do logarithms too, which, you know, you might not do until pre-calc in some other ones. And these are all things that you would totally use in engineering stuff. And complex numbers, actually, well, if you want to go into electrical engineering, you're going to use complex numbers a little more. But I haven't run across, I mean, if you do vibrations also, but that's like, you need to take linear analysis. You need to take differential equations before you can take vibrations. Okay, so we got this, plus, I am not getting a common denominator for this. Who care? Okay, so we say 4 times 0 I might need to put the next one on another page. No, I got space. 0 minus minus 1 over s, 2 minus s. Let's see, if t is 0, then I guess e squared? Okay, the thing you sent me contains stuff I don't know how to do, so by extension I'm dumb. No, that's not true. According to my brain? No. The reason I sent you that was because, like, if you don't know where you are in that course, like, going into it, right? Because that's a test for, like, the entire course, essentially. That's like me sending you a final for the class and saying, like, okay, like, what's up? Like, what do you know? You shouldn't know how to do all of it because you haven't taken a class on it. So it's more just like, where do you want to start in the different units? So like, if you're like, okay, I like know how to answer these questions. They're asking me about lines or like slopes and stuff. But if you came across a question, right, like about slopes, and you were like, oh, I don't know like this thing about slopes, it might be better for you to actually start like with that unit instead of a later unit, because, you know, part of it, but not all of it, you know? For e to the 2t, I guess the weird part is that it's 2t. It's a shift of e, it's a shift of 1 by 2. I think, I don't know, this one might be wrong. The jury's out, okay? Because there's an e squared in here and I don't think that's right. Because if it's 0, that feels very wrong. We're gonna leave it though. I'm gonna put a star next to it. Put a better colored star. There we go. I love drawing stars and things in my work. I think they're just very beautiful. Oh, I have to evaluate this. Okay, I can't answer anyone by the first question. That's okay. That's totally fine. It's good that you know how to answer the first question. Good, like, cause, okay, again, like, this is the same thing with Blaine. I don't know if you remember Blaine, but, like, he's the guy who asks the computer science questions and stuff in here. And it's like, he's like, oh, I'm, like, so dumb, I, like, don't know how to do it. And I was like, dude, you're teaching yourself the whole class. The professor isn't teaching the class. That makes you the opposite of dumb. You're, like, way smarter than people who, like, you have to put in so much more work, you know? Watch videos or whatever and not absorb any knowledge. Hey, if you want to take notes, if you want to wait until... I'm still going to be streaming for a while, but, you know, if you ever want to, like, just start taking some notes, you know, those videos are... They're pretty concise in terms of, like, if you were going to lecture, you'd probably get, like, go to a lecture, you'd probably have a professor talk about more stuff, like, less stuff in more time, essentially. So if you want to take notes on those videos, it'd be good to take notes on them. If you want, also, like, if you haven't really taken, like, math notes before or something, like, I can give you some tips, because I have honed my math notes pretty cleanly over the years. So this is gonna be 0 on both of them. Then minus... Okay, when t is 0 here, this is gonna go to 1, so... I feel like this is wrong, but... Because this should be... Oh. It might be right, actually. Sort of right. College algebra, is that what you learn in college or what? Yeah, that would be like a college, so like geared towards college students, but like an algebra course that you would take in college, yeah. But the thing is, like, it's still algebra. How did did he literally just ask me for the Laplace transform of cosine and I just like didn't do it right? Why do I have sine in here? Oh, because it's sine of t. Oh, I definitely did something very wrong. Oh no. Okay, we get 14 units. Yeah, there's a lot. But the thing is, like, this is going to be a while. That is both Algebra 1 and Algebra 2 and some pre-calc is the thing. So I might recommend that if you're trying to, like, if you're trying to get a leg up on something, I'm just going to redo this problem later, low-key. If you're trying to get a leg up, it's going to be faster than taking 3 different courses. Fair? Yeah. I'm always around. If you do want to, like, do it, then, and you want, like, somebody to be like, oh, hey, like, you want to impose a schedule on yourself, I'd be down to help with that, too. I can do, like, questions on stream or whatever. To the best of my ability, my algebras. I'll just starting. Hell yeah, man. You got this. I believe in you. It's great to learn about a schedule. For learning? Yeah. Are you taking classes over the summer? It's a great time to start. It sounds too healthy. Oh, but it keeps you on track, right? Like, you can always go faster than the schedule, but if you wanna, when you start getting into those low lows, you know what I mean? Oh, this is so nice. We're gonna just do some partial fraction decomposition. We're gonna chill out. Oh god, it's 3 though, which is means I probably can't do it in my head. Oh wait, yes I can. Plus plus minus. Oh yeah. Wait, no. Fuck. 4. Okay. Okay, I have -3. How do I get to 4 with -3, 2, and 1? Well, it's probably gonna be multiplied by 2. No, this sucks. We're gonna do regular partial fraction decomposition. Okay, so a times s plus 2 minus 3 plus b times s minus 1, s plus 2 plus c times... Wait, why did I do b like that? S minus 3. I don't know what a schedule... when do you suppose I learned then? Let's see. Well, so... What kind of stuff do you normally do for class? Like, I guess, like, how much time would you want to spend on something in your life? Because if your school isn't teaching you it and you want to learn it by a certain date, then that's a good way to start a schedule, right? If you're like, I want to learn this, like, in a year or something, or I want to learn this in 6 months, or I want to learn this in 10 weeks. You want a quarter system, or like 12 weeks if you want a semester system. I think it might be 13, I don't remember. I think that's a good place to start. And then saying like, okay, well these are the things that I have to do in my life. Like, nearly 15. Nearly 15, like, what? Like saying like, okay, these are the things I have to do, and then you know, seeing how much time you have, and then you can kind of split it up. You have 15 years you can learn it in? Well, that's a long time. See, -3 plus 2 is -1. Good. I can add numbers together. No, I am. No, I know. I'm joshing you. I figured it was that. I would say maybe a good schedule is try to do... You kind of have like 2 paths. You could try to do a unit in a couple days, or you could do a unit like in a week. I would say maybe try and just start on 1 unit and say, okay, well, I'm gonna work on it. Maybe don't say like every day, because it's kind of hard. Generally, like my classes, the one that I have the most is 4 times a week, only for an hour. So saying like, okay, I'm gonna do like an hour on Monday, an hour on Wednesday, an hour on Friday. if you have that time. Or saying like maybe, okay, I'm gonna do like 2 hours on Tuesday, 2 hours on Thursday, gonna see if I can like do a whole unit in that time. But since you probably haven't had as much rigorous like math stuff, it might take you like a little longer. So if you wanted to do like 4 times a week, like 1 hour, you know, however long. I think the thing that I know, for me at least, about math stuff is like I kind of cap out of productivity at about like 3. I can do 3 usually when I'm like not streaming. But you know, it's good to know your limits. But yeah, I mean, like I remember I was trying to learn like electrical engineering before I went to college, and before I had started physics 3, and I just like didn't make a schedule, and I was like, I'm gonna learn this, and then I like just didn't, you know. So is that minus? Yeah, minus 2c. Ooh. Look in the Discord real quick. 1 second. A plus B plus C equals 0. Linear combinations, baby. Minus A. I'm just gonna shove this in a matrix. Minus 4B plus C equals 1, and then minus 6A plus 4B minus 2C equals 4. We love partial fractions. And then once I get to that, then the answer is quite trivial. Me, productivity, go to school, end of school, 3 to 4 a.m. Well, maybe go to bed earlier, but hey, you know what? If your circadian rhythm is like that, some people like night classes. That's why they take, like, I have a 6 p.m. to 9 p.m. class in college, right? Like, there were enough people who, you know, were willing to take that class. I go to eat at 11:12 p.m. That is so specific. I would say, because like your school is probably like you don't have like free time like in your day. Like I had free periods when I was in high school, but I would assume you maybe don't have time. I don't know why I just wrote A equals twice. Okay, I'm losing it clearly. But you know, I would say just do it during school. I have break lunch and that's it. Yeah. Probably not the best time for studying. I'm just gonna pop this into a matrix, by the way. This is a 4x3. Sorry, 3x4, rows by columns. Yeah. 45 minutes? Honestly, if you were to commit that 45 minutes like each day, that would be like more than enough. But that's a lot to commit to, you know? Oh my god, I have all my old EE numbers in here. Ew. Okay, what? So different. 1, 1, 1, 0, -1, -4, 1, 1. The other ones were like -32.2. -6, 4, -2, 4. Okay. I could eat lunch in. Oh, it's not free time? No! Don't. No, you gotta eat lunch. You gotta eat lunch. You gotta do that. Very important. Don't. It's not good for you to not eat. Ooh. Oh, I think I did something wrong. Did I get the wrong matrix? Did I not put it into B? Okay, let's see. I mean, I guess it could be 1/8, but... in 2 15-minute bursts? Yeah, that seems suboptimal. Yeah, I have a social life. No, go have a lunch. If it was a break, like a free period, then... Okay, so a minus 6a. Did I multiply that correctly? Let's see. S squared minus 3s plus s, negative s, minus 6. Good. See, you're already doing math. S squared minus 3s minus 3s plus 4. Oh, I wrote plus 4. God damn it. What am I doing wrong? CS squared, yes, plus s minus 2. Don't know what's wrong. Looks all right to me. Dun, dun, dun. Oh, you don't have a laptop? Oh no, wait, that's... Oh. I would say just do it at home, King. Maybe it is negative... What is 0.8125 as a fraction? That's an eighth, right? Is it really an eighth? Ew. Okay, here's what we're gonna do. Here's my awesome strat. Okay, I could have done this problem in 5 minutes by going like this. Okay, f of s equals a times 1 over s minus 1 plus b is 1 over s plus 2 plus c times 1 over s minus 3. Oh, let's do the Laplace transforms for these. Oh wait, is this... I just say break is my least productive time. Okay, so we've eliminated break. Who's pinging me this much? Why is there 5 pings? Oh. That was a good ping. I thought there was something like on fire. I spent at least 4 minutes just trying to stay awake. Well, I mean, you could just whenever I'm streaming, you could also just work on it. Big brain. Okay, find the inverse Laplace. I'm assuming he just is gonna let us use it with form recognition. He doesn't say explicitly. I also can't integrate it. What am I talking about? Okay, s minus 1. This is an e. A e to the t plus b e to the negative 2t. Plus c e to the 3t. And now we just have another differential equation. I think doing it at school is impossible. Yeah, that's fair. Don't do it at school. Big brain. I personally also think, so like, a big part of when I teach or when I learn is, like agency or like ownership over content. And I think honestly doing it at home, being able to say like, this is how I want to do it, this is the way that I'm doing it, is a really valuable thing to be able to say. I asked about doing, replacing Maths with Khan Academy since it's taught me more in 10 minutes than school has in 2 years, and they said perhaps after you complete this schoolwork we allow you to do. Man, I mean, yeah. I feel you sometimes, because like, it's hard because, like where I am, right, professors want people to learn. They want people to learn. They just don't really understand sometimes that the way that they're asking people to learn, like the amount of work they're asking them to do, or the problems they're asking them to do, or whatever, isn't how people are going to learn. And like is kind of, doesn't work with their schedules or whatever. But like where you are, it's like your teachers, like, they clearly don't care about teaching you. And like, that's like just insane to me. Like, why would you not, how can you, like, how can you be a teacher and not teach people? Like, you should not be a teacher. you aren't a teacher. I don't, like, there's some professors where I'm like, they're a professor technically, but like I wouldn't call them a teacher because they're not teaching enough to be, like, it's kind of like if you alloy a metal, like with, okay, I alloy a metal with 0.3% or like 3%, you know, nickel and 97% copper. It's like, okay, that's mostly copper. But if you alloy it with like 55% nickel and like 45% copper, you are no longer a copper alloy. You've become a nickel alloy. And you can't just like be a teacher and not teach and be expected to like be able to be called a teacher. That's what I think. My English teacher gave me the equivalent of detention for correcting her. Oh my god. Your teacher writes on the whiteboard and just types on his computer sometime. Like, he doesn't even talk to me when I enter class. Oh my god, dude, I'm so sorry. Like, what's the point of you being there? Oh my god. I'm gonna make this a little different, by the way. So we're gonna do a over s minus 2 plus b s plus c over s plus 2 s squared. Maths, you just give me more of the same work and calls it harder. Yeah, I would not. I learned very young that don't ask professors for like permission, or teachers or whoever for like permission to be able to learn more. You can always find a better person. I've only had a couple teachers where I'm like, this teacher is so good that I would actually choose them over other teachers and like continue to go back to them and like have you know, like a good relationship with them. Like, you're not beholden to them. You know, you can go wherever you want. If you want to read a textbook, if you want to go to 3 Blue 1 Brown, if you want to come to my streams, if you want to go to whoever, like, you are in control of that. They all left? Wait, all your favorite teachers left? Oh, that's so bad. Oh my god. Dude, I feel so bad. It does get better, I will say, but god, it gets better later. Like, I don't want to be that guy, you know, but because I mean, you know, I understand like how soul crushing that is. Like, you can't, like, what are you supposed to do? Poor thing. My favorite teacher got into an accident and is gone because one of their arms is paralyzed. Oh my, well, okay, that's tragic. That's very tragic and sad. Why does this not have an S on it? Oh, it does. They're recovering? Oh, that's good. Oh wow, it's just an A, I see. Negative 2b plus c equals 0. Doesn't equal 0, equals 2. And then a minus 2c equals 3. Have you considered that Scribble is just making things up? No, I've been talking, Scribble's been in my chat for like 2 years, so I kind of know him well enough that like, I know they're not making shit up. Who is this guy? Chatter Andy. I mean, like, yeah. But also like, okay, I don't know. If somebody's making stuff up, like, well, I'm like too neurodivergent to like question it if somebody just, I thought they were a bot. Hey, don't be mean. It's a fair point. I'm too neurodivergent to be like, oh yeah, but you're making that up. I'm not gonna believe you. You're fine, you're fine. The username. No, it's funny because people with usernames like that are sometimes like, I'm a bot. Oh my god, wait, there's so many people. No way. That's so cool. We have the first like Turing test bot in my chat right now. No way, guys. Bots all over. Beep boop. I love that. That's a good name. Let's do some actually interesting math. I'm sorry, I'm an engineer. This is what I got, man. If I was a math major and they were teaching me stuff, sure. But I don't, unfortunately, I don't get to do that. I need 3 by 3? No. 4. 3 by 4. There are lots of really good math people on Twitch. If you wanna watch math people, and Stucky is really good. There are a ton of people in the space that are much more apt at doing math than I am, but I like doing math, so. But it's more of a zen sort of like, this is brainless, you know? Although I will say Laplace transforms are beautiful, and they are lovely, and I think that they are, they may not be the most, like, rigorous math that you can do, but I quite enjoy doing them. What do I need? Sorry. Buttons real quick. There we go. I think since I joined my school, it's only gotten worse somehow. Institutions can be like that. These numbers are also bad. Why are they like this? I'm gonna leave them. I mean, I guess I don't really need to leave them. They're sort of not bad, but they're just slightly bad enough. But I mean, these are problems he made. They pay you to keep being there? What? That's interesting. Did I write it like that before? Yeah. Okay. Cosine and sine. Okay, S over... Oh, that's so nice for me. They did my job for me. Every qualification you get... I don't know how much 50 pounds is. I was gonna say euros. Is that... I don't know. You get anything before year 11, or God forbid you leave, you get nothing. Huh. That's really interesting. This is e to the a, e to the 2t. This one is cosine. This one is sine. We could have done that with the annihilator method. 62.44 United States dollars. Man, if they paid me money to do... Actually, well, no, my classes are pretty boring. I don't know, I just think about civil engineering classes and I'm like, man, it's boring sometimes. But then there's this, and this is fun. And then, you know, you get to model vibrations on a drum, and then turn that into, like, vibrations on airplanes, and all that. It's pretty cool, though, that you can just model, like, something getting exploded. I love that that's, I think, the reason we use differential equations for engineering stuff. It's like, how do we model if I just, like, blow something up? That would be great to model. Right when we have that nasty behavior, how do we turn it into non-nasty behavior? How do we model that? That's our y. Oh, look at this. Y of 0 equals 0. We love that. Okay, let's see if I can remember how to do these off the top of my head. It's s squared Laplace transform of y minus y of 0 at 0 plus s, no, plus 1. I think that's it. Before I go running off my mouth, I should probably, let's see, I guess I should say minus, oh no, they're both minus, lol. Minus 0 times s minus 1 plus s Laplace transform of y minus 0 times s? I don't remember. There's another school that is extremely stern and taught exactly the way I want to learn, and I went there, it's all cool, and you got accepted into it, and yet you can't go there because you can't pay Transport costs? Ah, man, our world is messed up. That's so sad. Also, man, commuting is so bad. Like, my school is kind of out in the middle of nowhere. A little bit, not super out in the middle of nowhere, but getting on and off campus is always like, you just don't even have any parking, and they don't have enough parking. Put an asterisk on there. Council pays more money keeping me here. Yeah. What are you looking for? Oh, why? I think it's minus... minus something. Oh, minus f of 0. Nice, minus 0. Oh, oh wait, did I goof that? This is honking outside. I don't really live by a real road, so it's kind of weird to... Every time I bring the school up, people are like, oh no, you're autistic, how are you going to handle going to a real school? Oh my god, dude. People be ableist, truly. That's so stupid. It's like, can we just make our world more accessible so that everybody can have access to the same stuff? Like, or whatever stuff that they should be able to... What do you expect me to do in college? Evaporate? They probably don't expect you to go to college, to be honest. Which is really dumb. Okay, yeah, S. So 0. They do? What? That's very odd. Okay, 2e to the 2t. Or, sorry, e to the 2t. Let's get that sorted with. So this is going to be 1 over s minus 2. I'm like so confused. Yeah, geez. Okay, plus 1. Move the 1 over there. What have we got? I guess I'll do it out. S squared plus s. Oh yeah, the auxiliary polynomial. You know, I could have just done that and made my life a little easier, huh? I'm just gonna divide by it though. I don't need to... They don't need to see how I got that. Okay, can we factor this? Test question. Yeah, we can factor. Oh, multiplicity? No, wait. It'd be 2... Wait. Am I stupid? Maybe a little bit. Let's see. Oh wait, can I do that? Or do we need to complete the square? I suppose... I think I need to complete the square. Because if I did 2s... Wait, what would this be? There's 1s, it would be like 1/2, right? And then 1/4? Ew. Project that required curve fitting was scrapped right after I figured out least squares? Ah, man. Dude, that's awesome that you figured out least squares. Okay, so we got 12 over s minus 2. Maybe if I no, I was gonna say maybe if I multiply this out it'll be better. I don't think it's gonna be better. I think it's gonna be bad, actually. I think it's gonna be bad and sad. Okay, how do we wanna do this? How do we want to approach? I could just partial fraction decomposition with the s squared and do like like a bx plus c type thing. Then I immediately forgot least squares because I stopped holding the plug, keeping all the information. I think for me, I've always had a very good memory from what I can remember since when I was a little kid, so it's funny because like my professor, he was like, you guys gotta get on these transforms, buddy, because they're gonna get out of your brain if you don't do them every day. And I'm like, I looked at them once and I remember them now. So my memory's always been kind of terrible. I think it was just because I don't know. I've written one thing in memory at a time. That would be so hard to deal with. I like, so much of what I can do is hinged on me being able to like remember stuff, you know? Like, I mean, I also journal, which helps a lot. So I like write down stuff I remember. Doesn't have time to transfer long term, just disappears. Am I like really dumb about factoring this? I have to be able to factor this right. S plus 1. We'd have to have like S plus 2 here, and that would be S plus 3 in the middle. So no, I can't. What would be the -1 plus or minus the square root of b squared? Am I gonna have to complete the square? But I would have to complete the square with an S? No, it'd have to be a fourth, right? Because we'd have to say like, okay, no, sorry, wait, yeah, a fourth. A half. S squared plus 2s plus, no, sorry, s plus 1/4, no, it'd be 1/4. That's a shift. I don't like doing that over there though, that's gonna be dumb. I think I'm just gonna do partial fraction decomposition for that one, and I'll just do this shift on this one. I meant figuring out how to implement the equations, not what the hell they mean. Yeah, okay, to understand like why we do least squares, you do have to know linear analysis. So like you have to know, sorry, linear algebra and differential equations pretty much. Well, okay, you can know like I don't know, here's my big thing, is like professors will be like, oh, you need to know this, 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 and this. I'm like, technically you don't. Like, for example, I can explain the Reynolds transport theorem to you. It's, you have a volume, and we're trying to figure out if this volume is moving, it's gonna move out of the volume, right? Some part of it. And we wanna figure out, we wanna keep track of how much has left, essentially. That's what Reynolds transport theorem is. So we know this area, we start with this one, and we say, okay, well, how much is in the box? Well, it's this area minus this area, right? And then minus this area. That's all Reynolds transport theorem is. That's a fluid mechanics problem that you solve with calculus, but you don't need calculus to know how to solve it because you can say what it is, right? Like, so for least squares, like you can understand like the idea of least squares without necessarily, you know, knowing the math behind least squares. I could probably try and explain like standard value decomposition to someone who doesn't know anything about math. Would it be easy? No. Would people maybe get it? Yeah. Have I explained, like, you know, to my mom or dad who hasn't taken fluid mechanics? I think my dad took fluid mechanics. But like, someone who hasn't taken fluid mechanics about the no-slip condition and how that changes the boundary condition of fluids with two different viscosities? Yeah, you could understand that. You go, put water on honey. It moves. Easy clap. I don't know. I think that I'm just like, I'm tired of people being jaded about stuff. Like, just because I'm an engineer doesn't mean I'm like inherently smarter than everybody, you know? Okay, sorry. I need to think about this. So this is square root of 3 over 2 for our like cosine stuff. Yeah, so let me just quickly multiply by square root of 3 over 2. Yep. Yeah, that's what that is. Okay, so what does this equal? This equals the, so y equals, I like the Laplace inverse of all this stuff, which I guess I should probably do. That was also a very bad L that I drew, but it's fun. Okay, let's just say a times, so as squared plus as plus 2a plus, okay, so I'm skipping a little bit, but b s squared, so it's b s plus c, so b s squared minus 2bs plus 2c plus cs equals 12. Nice. So what have we got? We got a plus b equals 0. A minus 2b plus c equals 0. 2a plus 2c equals 12. Yeah, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. I'm going to solve for a's and b's and all that dealio. Or, you know, I can just say this like I've been doing the whole time and just kind of hand wave it away. So Laplace inverse of, okay, so some a times 1 over, okay, plus bs over, oh wait, I gotta do the same thing I did over there in one step. He's literally just saying, he's like, guys, please don't do this in one step. the ABI is deprecated. I'll update it. It probably is just one command I have to change. Let me open that so I can remember to do that, actually. Let's see. What is it called? Nightbot. There we go. It's been deprecated for like half a year, I think. I'm not saying it hasn't. I just forget about it. Okay, fine, let's do this like properly. So it's gonna be bs plus c over, and I'm gonna do the same thing I did over there. So s plus 1/2 squared plus 3/2 or 3/4 plus, we'll just do this, plus, okay. So we have a shift of e to the negative 1/2 t. That's the first thing. And this is gonna be the times 2 over root 3. And then that one is gonna be sine t. Crazy. That's a fun guy. Like a mushroom, fun guy. Okay. Equals, so I'll pull out that a, that's gonna be a e to the 2t plus the Laplace inverse of, okay, bs okay, let me think about this. So if we have s over this plus 3/4, I think we're gonna just have the same thing as, no, I lied. Oh no, oh god. I need s plus 1/2. But then it's minus 1/2 over, oh my god, wait, it's gonna turn into two things again. We're gonna have like 4 terms here. Okay, s plus 1/2. I'm gonna add a 1/2, I'm gonna minus a 1/2, but I'm gonna take the 1/2, I'm gonna put it out. Squared plus 3/4. This is also not good, so it's gonna be times root 3 over 2, root 3 over 2. Plus 1/2 over, oh, this isn't good, but it's like extra bad. Because I have to turn 1/2 into, wait, can I even do this? Okay, so like the 3/4 needs to change. This needs to be also the same as this is the thing. So root 3 over 2. No, wait, we just want to change this. Sorry. It's gonna be fine. Times root 3, I guess, over root 3. Because we want root 3 over 2 on the top. Do I need to multiply for this? I don't think so. No, I don't, because the s should just be s. God, this is like a lot. Did I finish yet? No, I didn't do the c. Okay. Plus c. I guess it's just 1, right? So this is where we multiply by the 3/2, the thing we multiply by. Yes. Sorry, like I had to convince myself there. Okay, cool. Cool. Okay. Dude, imagine doing this with like linear 1. You would cry. And then I just need to put the coefficients in. Okay, what is this? This is a shift. So plus e to the minus 1/2 t. And this is a cosine function, cosine of t. And we haven't multiplied it by anything, so that's fine. Then plus this 1/2, this is a sine function. Is it shifted? Yes, it's shifted. So e to the negative 1/2 t sine of t times 1 over root 3. Yeah. Plus c. Okay, does the b apply to both of these? Maybe? Oh no. Okay, wait, does it apply to both of them? If we had bs... No, it wouldn't. It would just apply to that one. Really, it only applies to the s, not the 1/2. Oh, that's so... It's fine, I think. I think it's fine. I did forget to write the b here, though. That's a b. Do I need to say, like, 1/2 over b? I don't know. What is c? I don't even know what's going on here. Okay, this is a sine. So it's gonna be this. It's gonna be basically like the first this one. E to the negative 1/2 t times 2 over root 3 sine t. It's like, yeah, plus, and we have another one. Wait. Where did that come from? Oh, that just came from, yeah. There we go. Simple as that. Simple as all of that. It really only started to get bad, like, at the second to last line. It's honestly still, like, pretty decent. I don't think it's very tricky. It's kind of just like, doop da doop da doop. But that's like it. I mean, okay, so that that product of two integrals thing, we don't like that one. I don't know where to go from here. I guess I could just kind of look into it a little bit more. Product of two integrals. Okay, I googled it before, let's see. Multiplying two integrals becomes a double integral, question mark. E to the negative x divided by 2 dx times e to the negative y divided by 2 dx equals double integral. How come this is valid? I assume it's not generally true because it doesn't seem like you can go around mashing integrals together. Yes. Oh, because it's two. It's two different variables. I did not know that. That's fascinating. That's actually like, whoa. Dude, mathematical. Okay, 0 to infinity on both of them. We say 1 over 4xy e to the negative sxx sx squared. Have you seen how you work out the Gaussian integral? No, I haven't. I would love to see though. Low key, I might just go look that up right now. This is kind of goofy, this integral. Let's see, Gaussian integral. I don't even know the Gaussian integral, man. Maybe I have seen this actually. The probability integral, the ERF function? Okay, never mind. Oh! Wait, is this like Gaussian distribution? We did not talk about how we actually do the integral. But we did talk about, you have to do it like numerically, right? I mean, integrate from negative infinity to infinity. Oh yeah. Here, wait, we can pop over to, I think if I, no, full screen I shouldn't have my changed. Oh, I like how it picks up me. This thing? Trick of combining two one-dimensional Gaussians. So e to the negative x squared. Oh, it's the square root of them squared. Wait, this is kind of similar to like what we're doing for this one. Oh yeah, and then switching to polar coordinates. Wait, that's exactly the same way that we're doing this one. Well, it's just square root of pi? That's crazy. Exactly, that's so cool. The simple proof that does not require transformation. 0 to an upper finite can be given by the continued fraction ERF. Sorry. ERF. I like that. The general class of integrals of the form can be solved analytically by setting x to the negative. Oh, that's so cool. Y squared equals ax squared. Where n's a double factorial? Oh my god, dude, double factorial is crazy. That goes hard. That's like the hardest thing ever. Double factorials will crush all. You can also differentiate with respect to a. Is that this one? I think this is this one, maybe. Oh, differentiate. No, this is, they integrated for that. A related often useful integral is h of h sub n of a for 1 over square root of pi. Ooh, this is, It's a little hairy. That's so cool though. Earth. I've never heard about the multiplying two integrals into... I feel like someone would have mentioned this before. Like, I feel like that's a pretty big thing that you can take two integrals and like that are in different coordinates and multiply them and get a double integral. But I mean, I guess it kind of makes sense because it's like, oh, well, one of these integrals represents like this area in this direction, the other one represents area in another direction. And you multiply and you get an area. That's like, actually, I'm actually kind of like astounded. That's pretty cool. The double integral backwards. Okay, I know, but it's cool. It's cool. I've never seen it before. I'm very easily excitable. I have to change this to polar? Oh god, how do I do that? It's been more than a year. Okay, let me think. RD theta. I remember. I might need to pull out my old notebook. You also think of the integral as a sum, and sums you can change their order or do it as a double sum. Yeah, you can do that. You're right. That's pretty cool. Pretty swag. Where is my Calc 4? There's somewhere. Is this Calc 4? Sorry, this is not Calc 4, but I just found me saying, I'm tired of being tired, I need to boy boss in my notes. Apparently, right next to where I wrote, apparently my professor shoplifted in 5th grade. This guy does rule, and he gave everyone bugs to eat. Where's Calc 4? Please. Oh wait, this is multivariable. I need to read this again anyway. I miss change of basis. I miss change of basis so much. Bugs? Yeah. RD theta is correct. I just don't remember how to do it. Yeah, I think he like gave everybody like chocolate bugs. I don't remember that story. A Green's theorem, not that one. He was a funny guy. He was like a surfer dude. Not really. He just sounded like one. That's what happens when you're in Cali. You can either draw a triangle or use the Jacobi. Oh, I don't know. I don't know either of those things. Oh no. Yeah, I love how he just said, no, there's a, I remember vaguely. Wait, I remember. Wait, can't I just say, like, x equals r cosine theta? Hello, what are you doing? Hi, Storm. Oh my gosh, it's been so long. A triangle's a shape with 3 sides. Thank you. I do know what a triangle is. Here we go. Oh wow. Oh, I did it, poggers. We're doing, I'm doing Laplace transforms. It's basic. Okay, it's basic. I should specify everything I do here is like introductory thing with respect to mathematics. You want to solve your double integrals? Yeah, I'm trying to convert it to polar. Because x equals r cosine theta and y equals r sine theta. But I don't remember if that's how we do it. Probably. It's gonna make this really kind of ugly though, is the thing. Can you just change a variable Jacobi? We haven't done that. I'm not allowed to do that. What was this? It's a 4, okay. My 4's look like my y's. That sounds cool as fuck. I don't know how to do it though. I don't even know if this is like integratable at this point. This seems like I'm... No, you just get r squared in the exponential. Oh, okay. But yeah, I can add these. Oh yeah, yeah. S over 2 r squared. Wait. Oh, never mind. We're chilling. Well, you've got xy and 1 over xy. What? Wait, what? Wait, what? Oh. Oh my god. Oh my god. Oh, I'm so smart, guys. Guys, I swear. Guys, I swear I know what's going on. I feel like it's funny because, as an engineer, I'm pretty decent at knowing, like, what's going on for math. But the thing is, like, when any math major sees me, it's like, dude, you're just, like a little bug in a tank. You just have a Gaussian integral here. Yeah, that's what they were saying. Your integral limits, you're so right, they're not this. What is it? Let's see. So if x... Okay, if x equals 0, I need it for... I guess... Would r still be... Wait, r equals... squared plus y squared? I'm trying to think in my brain. We probably want to do... Can I do theta first? Can I do d theta? R0 to infinity. Oh, yeah. Okay. That's what I was thinking. Hey. Doing the problem over here. Better than I am. Can I do theta first? Can I just say, like, what if I said 0 to 2 pi first? Can we... I can do that, yeah? Now you have u prime e to the u. U prime e to the u. Fuck, God, it's been so long. Yeah, I can. Oh yeah. I can just pop a 2 pi out, right? I can just say that this is equal to 2 pi times this because there's no thetas in it. Like that. Maybe I can. Do I have to substitute for this? Well, like if E equals like U, I don't have that. Do I? Wait, yes I do. Yes I do. Wait, kind of. Wait, no. Wait, what I'm talking about? Okay, if I had e to the negative s r squared, I'm not looking at chat because you're gonna be like, this is what the answer is. It's e to the negative s r squared over 2 times s to sr. Yeah? Do not need to substitute, yes. Okay, yeah, I figured I got you. It's been a long time since I've integrated anything. It's just really bad of me. Oh wait, there's another math problem I can do. Minus sign, you're so right. Thank you. So then we have a minus 1 over s, right? Wait. Yes. And then it's just e to the negative s r squared over 2. It's from 0 to infinity. Yes. Maybe. I don't even need the 0. The 0's gonna... Wait, but I need to change it back into R. I'm sorry, not back into R. I need to get that R out of there. What do I do? Oh, this will be the value of that squared. Oh, I just have to, never mind, I have to evaluate it for R. So for, okay. Wait, it's just 0 minus pi over 2s? Maybe? Yes? I'm like, chat, please backseat game me. So then that equals the Laplace transform of the it's squared. So equals the square root of pi over 2s? Yeah, maybe? Yeah, I feel like that's close, if not it. I think that's right. This is the least confident I've ever been. It's actually so untrue. I've been so unconfident before. I forgot there's an, oh, you know what? Yeah, I might do that other math problem. Transport theorem in my fluid dynamics. The result seems good. Yay! Claps my hands together cutely. I could just look up the Laplace transform of t to the -1/2. So I mean, I could check that pretty easily. I think I want to do this fluids problem. He's like, okay guys, if you can't do this problem, you need to read a calculus textbook. And I was like, yeah, it's just a calc problem. It's been a long time since I've done it though. It's cool though, it's cool. It's a little bit of fluid mechanics. Just like a skosh. But it's more about, it's like vector calculus, so. Okay, let me switch over. I might have my full name up on screen, so I'm gonna turn this off for 1 second while I make sure I don't have it up, because I think I still have my headers up. Yeah, I probably do. Okay, we're chilling. Finally, you did some math. It's okay, we're gonna do more math. We're gonna do more math. I know, I also want to do math. This is not math, but the thing that we're gonna do is math. Okay, this is the question. It's a long problem. Okay, so we have a velocity field. So just like a vector field. You know, classic. And we want to find the volume flow rate for this surface here. I have to switch my pen color. Your engineering stuff creates some fear. It's okay, I swear, it's just this, we just have to evaluate this equation, okay, over this area. That's all we have to do. Now the other side is like, you have to do it, he's basically asking you to just like, do it with calculus and do it with a different equation, but this one's the calculus one. So it's been a long time. All right, so for A, this is just math. I mean, like, if I can't do it, then so we have Q equals the integral over the area, so double integral of V dot dA. Okay. So what does dA equal? That's probably the best place to start, I guess. Well, equals a little piece of this. Yeah, okay, I can't just say it's not like dx times dy, because we're at an angle. It's gonna be how much we move in this direction and how much we move in this. Well, this direction is actually dx. So dx. Okay. That's a good start. Now this is gonna be the, I guess it's just gonna be like, okay, I'm using these as like differential bits. This is probably not right now. Just, okay, if I was gonna take the hypotenuse, it would be dy squared plus dz squared. A way to obtain it is to compute the norm of the vectorial product of a base of your shape. The norm of a vectorial product. Oh, so like you just take the vector of this vector. Where do the vectors have to start? Are they like this vector and this vector? Yeah? Okay, so I guess the zy one would be... Oh god, okay, how would I say that? I guess it's just like b? Well, this vector is gonna be, I guess, ax? No. No. I lied. This has nothing to do with ax. This is like x. Wait, do they have to be normalized, or are we normalizing them afterward? Okay, cool. Well, let me try that way. Let's do that. So I'll normalize them afterward, because I think that's what you said. You said compute the vector norm. So this is going to be, I guess, like 10i. And this is going to be... What have we got? I guess it doesn't matter if it's negative, right? Let's make it positive then. This is going to be... oh, it's negative. Negative 6... j plus 3 k. So if I write that in real vectors, 10, 0, 0, is it... Okay, let me think. A dot product is like an angle. Do we have to do the cross product of them? Oh, vectorial product. Yeah, cross product. Okay. So 10, 0, 0, 0, negative 6. Why am I writing it like that? Do I want to... Wait. Oh my goodness gracious, I'm blanking so hard. It's like... We're okay. You and I have to prove one thing. You'll obtain the normal vector of your surface with this. Oh, your area vector. Oh, that makes sense. Man, why don't they just teach us this stuff? That'd be great. Sorry, this should be a, this. Okay, so, I don't know. Just do it here. So is that? 0, 3, 6. Does that make sense? Let's see. 3 over in the y, up 6. Yeah, that makes sense. Wait, but so is that? Do I just... Oh, I get the norm of that. And that'll give me how big the area is? I think I might have started trying to do that over here. Okay, so this equals this is the area vector. That's like the whole ass area vector. Right? But I don't know if that's how we want to represent like the differential area vector. I did this time of calculus a long time ago. No, I think that's correct. But I think we want to say, because like if we say this, we can define these little bits in terms of this is definitely not right. We would want to turn this into something like... What would this even be? This would be like... That is linear. This is like God, we did this so long ago. or we did it also for a very short period of time, and it was like one of the hardest things we did, or one of the most interesting and useful things we did, but we didn't do it for a very long time. It was... Did I switch notebooks somewhere? First, it's like it's something about pathing. I'm determined to figure this out though before he just like steals it away. Second type of line integral. Because we talked about this for like conservative forces, like we would do integrals over areas and stuff. I just didn't do it that well, you know? It's Lagrangian multipliers, no. Maybe I had another book for Calc 4. It looks like this. Oh, that's Newton's law of cooling. Yeah, that's all linear. Because what I would think is like, okay, if we can say a dx, because the idea is then like we can break this up, right? So if we have a dx, then we can say like this equals like v of x times dx, like plus v of y times dy plus v of z times dz. Or sorry, like dotted. Would it be dotted? Let me think. No. No, it would not be dotted. And then these would be, it's not a triple integral though, is the thing. Or it would be a double, it needs to be a double integral because we're doing it over an area. Right? But our area is over... We're getting there. We're getting there. So our area is over this area. Our area is in 3 dimensions, but yeah, we might need to... Oh wait, no, I think we're okay. I think I need to project it, right? Oh, it's been so long. Yeah, okay. You know, you start by defining a map f of your surface, then you compute df dr and df d theta, then compute the norm of the vectorial product, and the integral will be... Yeah, but here it's a little overkill. I'm back and, what's going on? It's okay. We're struggling. I'm struggling. Storm, I think you're completely right. Your way is easier for this type of easy shape. Yeah, the point is that it's an easy shape. Because if we say like, okay, in the x something plane, like I guess we could say the x z plane, it's just gonna be like this, you know? But I don't know if that's what we would want to do, because like when you're saying like v of x dot d of x, our v of x is probably like, it's gonna look like, you know, something like, let's see, it's going positive in this direction, negative in this direction. It's probably going like this, right? Like flowing out from the surface. Wait, it's not even going up at all. Yeah, it's literally just flowing axi. I guess like something like this. That's kind of goofy. Sure. My method works for every shape. Yeah. Wait, oh, okay, wait, write the differential area vector in ijk components. Wait, that's what I started. Okay, I'll leave that. This I like. I'm gonna keep this just because I like that, because I like that we did find the area vector. So dA. It'd be like, oh wait, okay, wait, a differential area vector. dy j hat plus dz k hat? But we need to relate those to each other somehow. I love hate maths. Well, this is kind of fun because okay, the thing that I like about this class, at least, he doesn't really give a shit if we do the whole well. But if you just prefer to use Pythagoras here, yeah. He doesn't really care if we do the homework or not. He cares if he wants us to do the homework, but he doesn't collect all of the homework. So like, I can do it and I can say like, man, I'm just having fun. I'm just like doing whatever. Cause like when he just grades it, but he doesn't even give us like a lot of credit for it. So it's kind of like, I can just do whatever for it. You know, I'd like to get credit for it, but like, because I don't have to worry about it as much. So we can just kind of play around. Oh, okay. Wait a second. Wait, I need to write, should I just write the equation for this area? I didn't even do that yet. Oh no. Well, I have the vector. How do I write the equation for a plane again? Wait, I remember. I'm remembering my brain. It's something like 1 equals the intercept. So it's like, isn't like it'd be like z divided by 3 plus like y divided by 6 plus like x divided by 10. Is that the equation for a plane? Integral of v xyz dx dy dz. But we have to do the integral over the area, so it's like dotted with the area. Yes, did I get that right? No way. No way. It's crazy. Are these partials? Because if it, wait, is it like D? How do I know whether it's a partial or not? Okay, wait. I don't know whether it's a partial. I was gonna say, it's a plane. Oh yeah, baby. Let's go. Let's go. I remember something from my stupid Baka life, but I don't know if it's your plane. Wait, let me see. Let's graph it. See, here's the thing, is you're gonna, if you come to Damie VTuber's stream, you get an experience, okay? We get to explore whether this plane is like completely wrong or not. Z divided by 3. Okay, I typed Z twice. Okay, we've started a plane, plus y divided by 6, plus x divided by 10. X divided by 10. No. Wait. Almost. It's close. What the heck is going on here? The z is right. Oh, it's because the x doesn't intersect. So what if I just say plus x? No, that's also bad. Wait, when... Oh wait, it changed it. It's close. It's so close. Why is it like... Why is it at a weird angle? Try no x. I gotta go. Catch y'all later. Bye. Oh wait, you're so right. Wait, I'm so silly. I'm so goofy. Oh my god, you're so based. Thank you so much. You're winning. You're winning everything. Can I give you like... I would give you a badge that just says like... You get the winner. Shouts out to Boadi Kuden. Is it Boadi? That's insane. That's a crazy name. I really like it though. It's like Boadwee. Boadwee. Boad. Bradley. Oh, I just realized. Bradley, okay. I'd rather say Bradley. That would be like great for me. If these are partials, then I can just do the partials and then I can just do it. I can just do a dot product. When I dot a V with an A, is that how that works? Do I know things? It would have to be, right? Because like when you have a partial, when you have a let me just say like this is A. So like dA is equal to zero I hat? No, that's not right. It's not. Well, I guess if you no, it's not that. Oh, my brain. Okay, if I differentiate this with respect to like y, it's gonna be okay, if I took the gradient, it would give me 0, 1/6, 1/3, right? dA has to be a unit vector orthogonal to A. dA has to be a unit vector yes. Yeah, wait. Yes. Oh, wait. I need the normal of the plane. Wait, the normal of the plane is this. Right? I think so. Because you would say, like... it would be like this and this. Like that. That's what I explained to you. Yeah, no, we got that. We got that, Storm. Yeah, we got that. Don't worry. I remember that. But it's not little. It's a big vector. Right? Or is that actually the differential one? I mean, I guess that's the magnitude of the vector. It's not like it gets any smaller. But that's the area vector for the whole plane is the thing. It is not that. Oh, my brain. Wait. We're getting there. It's been a long time. Let's see. I mean, if I was just gonna dot it with V, that would be really quite nice, I guess. Here, we'll say that. Or this isn't A, this is like the plane. Which you can get a normal from. But, I'm gonna just leave it like that for now. What was V? A as AX. AX. So that's nothing. It would be 0. It would just be negative by okay, j hat dotted with j hat is 1, right? Like by dy, that can't be it. Compute a base of your plane and do what I said. Yeah. Okay, well, I could do that, but I feel like this is like not that bad. Wait, I just need to it's like parameterization or something, right? Let me see. Give me a second. What is this? I don't know what this is actually. What is this? What is this? Is this Calc 3 or? Oh, it's Calc 3. You have to forgive me. This is my. Can you show the dr the drs? don't know if that's what you meant, but wait, I just want to hear me out. I want to just look through some stuff real quick because I feel like there's something in my brain that like this is so familiar to me, and there's just one thing I want to find because I'm like I know this. This is my English notes. Where's my other? That's characteristic. ASMR paper turning. No, that's curvature. Why did I switch notebooks? And I didn't label anything. I still do this, so, you know. I can't get that past me when current me also doesn't do that. Is a lab notebook. Oh no, that's data. That's fine. Oh, it might be... Here, maybe? Question mark? That's proof, that's physics. Man. Oh, this is like old. Oh god. I don't know if I can find it. I just want to find my reparameterization notes. No, I know it's my normal vector. Guys, I swear I know it's my normal vector. I just want to remember how to do a dot product thing with the area vector again. This wouldn't be it, would it? The math is so winning right now. I'm not winning the math. This is old one. It's on my California book. Aha. Is it this? This is literally the only notebook I have left in my drawer. This is like dynamic. This is just the depressing, sad music playing in the background. Guys, you don't understand. If I don't find this, like, I'm not gonna trust myself. You know what I mean? This is E. This isn't it. Maybe it is. No, that's... Damn it. Wow, I really, the one thing I need when I need to find something, I can't find it. Well, fought a good fight. It's the end of this, maybe? Oh. Slanting. No. No. I don't know. I can't find it. That's depressing. I'll go to sleep. Good night. Bye, Storm. And the only thing I don't get is I have a normal vector. Is that normal vector? Is it like differential? Like, do I have to normalize it? Oh, maybe I just have to normalize it. Will that make it okay? I feel like you can't just say like, oh, let me like use the area vector that has like stuff on it, because it's not small. Like a cross product is about, or sorry, a dot product is about magnitude. So like, right? We need to have something where we can like have it be small. And even then, if I normalized it, it's still like, well, maybe if I just normalize it, that'd be like Vx dot Ax. Like divided by, what would that be? 9 plus 36. I guess I could just pull 9 over 36 out of everything. These are both vectors. V dot A is short for V dot with a unit normal vector. Okay, so it is unit. Okay. I think that's what was tripping me up. Cause I was like, it has some like, you know, it's little. Like I can't just shove a whole ass vector in there if I'm trying to say that it's little. Okay, granted, that's kind of a dumb way of saying it, you know, like, but you know what I mean. Okay, I really didn't need to do that. What's 9, is that factor, not factorable? 45? No. Okay, fine. Alright, I need the V then, so AX. I'm just gonna keep it over the area for now. I guess D. No, AX over that, yeah. So AX times 0 plus or minus 1. Oh, times 6. And then I'll just pull it out in front. 1 over root 45. But where do I put the... I need like an X and a Y, like... Right? Would this still be like dA? Like the whole thing times dA? But it's not, because I dotted it with dA. I did it, man. I'm so mad because we did this with like work. We literally just did work functions in my Calc 4 class, but I do not remember them because it's been a long time since I took that class. Oh, I'm so mad because I remember sitting in class and doing it, and I was like, yeah, I remember how to do this, and I just haven't done it in a year. Your DA is still there? Wait, where are the DAs? Are they just here? You changed from vector to scalar DA. So this would be dA. Yeah? But it's 1 is the thing. No. dy. Yeah? Because it's like... That's the component of A in the y direction? Maybe? I don't know if... dy be integrating over a length. Oh, so it is just dA? Oh. Wait, but that's kind of weird, because it's like... Okay, if I dot... Like, let's say I dot... Right, it's like AX... Or sorry, A negative B. Dotted with our unit, which is like 1, 1, 1. But that would just equal like negative B. Or is it negative 1, is it like negative, is it like dA, dA, dA? Or is it dx, dy, dz? Or is it dA, dx, dA, dy, dA, dz? That's not, I don't think that's correct either. It's been so long. dA is dA scalar, okay. Okay, that makes sense. So then it is just like 1 times dA, got it, okay. Me with the littlest baby boy math going, why isn't it that way? Okay. We can change it, we can change the bounds. Okay, so we want to go from... We want y as a function of z? Question mark? No, we want to move along the zy plane that we have, and we want to move along x. Right? So x will be like 0 to 10. And then we'll have... What is it over here? This is it. That's this thing, right? That's like this, and then we want to like go... Nope, that's a volume. Okay, so I need to solve for, I guess, like, either y in terms of z or z in terms of y. Let me do y in terms of z, because that'll be y equals, because it'll be like 6, so y plus 2z equals 6, so y equals 6 minus 2z. You know, the one thing I do enjoy about this is, like, because I'm struggling so hard, what exactly is the problem? Wait, like, is it like, what exactly is the problem with me not being able to do it, or what is the problem asking for? It's just asking to literally just to do this with math and in my... I just need to turn y into, wait, no I don't. What am I need, well, because I need to... Wait, no, it's not a volume. Oh my god, it's not a volume. It's not a volume. It's not a volume. Oh, I'm just going on autopilot. Okay. We go from... Okay. I just like, okay, if it was here, if it was like here and it wasn't tilted, I don't think I would be having as much trouble with this. Because if it was here, it's like, okay, well, you just say like x from 0 to 10, z from 0 to 3. Okay, good. V is velocity? Yeah, it's a velocity field. It's a flow rate, so we're saying we have a flow of like water or some fluid, maybe it's a gas, whatever. And it's flowing like this, sort of. And we're just looking, it's sort of like a flux, like we want to find the flow rate through, so like how much stuff is going through this plane right here. Where is it flowing? It's flowing like everywhere. So it's defined for... Wait, why is it not... Wait. It's not, but it's not flowing in the Z. Why is it only flowing through? Wait, what? Wait, it's only flow, no, question mark. If it's not flowing in the Z direction, oh no, it's defined for like all these places. It just means that it's not at an angle in the Z direction. Do I not, no, it's, so Q, okay, how do I explain this quickly? Sometimes we're interested in, have you ever done, like any electromagnetism? Wait, for the given velocity. No, it says use the definition for, yeah, this is the velocity field. But like, I just have to say like, that was this negative b. That's why we have a negative b in here. We'll just end up getting like a thing with like stuff in it. A thing with stuff in it is the worst. I'm just trying to figure out like for my dA, what variables to use, because if it were here, I could just say, okay, then like, you know, the area vector is in x and y, and then I just integrate over x and y, and then like there's no, you know, whatever flowing, sorry, x and z, and there's no whatever, but like, because it's in 3D, my brain is like, you shall not pass. I think I just need to say this. I think I just need to say for, I I think I might need, I think I have to relate y and z though. There's no way for me to not do that. So that would still be the y equals 6 minus 2z. You could rotate it so the rectangle's in the xy plane. But if we rotate it, then it changes the amount of stuff going through it. Sort of like if you, the example they use when they talk about it in like EE is like, let's say you're you're in the wind, right? Unless I rotated the velocity field with it, which I guess I could do, but I'd have to just like do a matrix transformation. It's like if you have a piece of paper, like if you rotate it, obviously it's going to capture a different amount of wind. You rotate everything. Wait, but you should, okay, there's no way you can't just integrate over this though. Like that's silly. I should be able to do like 2 variables. Right? Like okay, okay. How to integrate over a tilted plane. There we go. Surface integrals. Paul's online notes. We love Paul. Paul's my savior, dude. Oh my god, how have I been trying to do this problem for like an hour? Okay, standard double integrals. The integral on the right is a standard double integral. Substitute a surface in for the integrand and then add on that messy square root. Oh, it's because there's a formula for it that maybe we just never did surface integrals. I think we did some, but we just like didn't do it a lot. Let's see. f of xyz ds is the surface, which is f of xy g of y. Why do I have... Oh, okay. Sure. Here, wait, let's go over here. Come with me. Come with me on a journey. f x y g of y. Yes! Wait! Okay, I remember this. Okay. No, you know what I should look up? I should just look up, this is multivariable, right? Are we on multivariable? Calculus 3, is this multivariable in Paul's notes? I don't know. It's reparameterization. It's like, area and volume surface integrals. Let's see. One problem there was integrating over plane. Portion of plane, yeah. Okay, so x equals 1 minus y minus z. We need to determine what d is. Okay, sure. Notice the x's are labeled differently than we were used to seeing in the sketch of d. This was to keep the sketch consistent. Yes, I'm vaguely remembering. Okay, the integral surface is not in form z equals gxy. We can't use the formula above. However, as noted, we can modify this to work for it. We have standard right. We'll substitute the equation in for z in the integrand and then add on the often messy square root. After that, it's a standard double integral, and that we should be able to do. Yes, okay, I can do a standard double integral. Where's the d, though? Okay, so in some regions, d lies in the xy plane. Let's see, surface is not in the form of... Okay, wait, how do they modify it? 1 plus... I don't see how they modified it. Oh, I see, so they just said x. Okay, that's fine. They just changed there instead of saying x and y plus 1. Yeah, that makes sense. Formula changes should be somewhat obvious changes. Okay, let's do the integral. Okay, now instead of doing that, I need to say... I want to say we're doing a... But so I don't want the area on the surface as the thing. Although I do want to say, like, okay, I want this as a function of x, oops. I want it as a function of x's and y's. So if I say y, I want to say it's this. 0 to 6 minus 2z. But I think that's not it. If I just say y, what's the space in y that we're moving over? We're going from 0 to 10. Sorry, 0 to 6. And then we're going out 10 in x, but it's not exactly like that. Can I just do, okay. Can I just do it? This is an insane thing to say. Can I do a triple integral and just say that there's no thickness? Because that would give me just a way to say, like, okay, well, z, you go from this to this, and y, you go from this to this. Right? I don't think I can do that. I feel like that's, like, illegal. That's definitely illegal. I don't know, man. It's probably reparameterization. No, let me see if I can actually look up, I want to look up, like, multivariable calculus, like work functions. Computing the work done by force field. That's like what we're basically doing here. Functions of several variables. I think that's not it. Let's see. Nope, yeah, that's not it. Okay, that's literally just like the beginning of Calc 3. I want to do like dot product. Calculus with vector functions? No. Velocity and acceleration? No. R. Hey, what's up? I'm malding over not being able to do this insanely easy integral. But it's okay. Making a sandwich right now. That's awesome. Double integrals over general regions. Okay, no, I don't need that. I want a double integral over a three-dimensional region. I don't know what. Wait, change of variables, maybe? Toasting bread? Ooh, that sounds good. What calc branch is this? This is applied multivariable calculus. So this is like, this is a very bad example, I'm sorry. I'm a little bit more of like a funny man than I'm gonna lecture all the time, man. But, okay, potential functions. Oh, I remember these. Oh, sorry, I'm looking up, here, look. 3D space thingy. Yes, 3D space thingy, indeed. We're trying to find a volume flow rate. But it's been a long time. Let's see. Find a potential function. Oh, no, that's not this. That's not what I need. I want, like, parametric surfaces? Question mark? I don't know why he doesn't have... I don't know why he doesn't have, toast done? Oh, yeah. It's like, I want the work, functions is the thing. Maybe it's not this. Functions of several variables. I want like the work done by using a line integral to find work done. Computing work done by a force field? Kind of? Not exactly. The integrals of multivariable calculus. I just don't know why. We have this one, but like again, we don't want the area. We want an area of like, oh, physics? Yeah, it's physics. Or fluid mechanics. Like I don't need the area is the thing. I need a let w equal 3y plus 6z, then w is a vector in your plane, so you've reduced it to integrating over a coordinate plane. Wait a second, I need to think about that. Cheese and salami? Oh, that's a good sandwich. That's an awesome sandwich. 3y plus 6z. Oh, wait, you're so smart. Wait. Wait. That's huge brain. Then... And then I just have to say y equals... We just change the limits of whatever. Okay. I feel like I should be able to figure that out. Wait, because we were there. We were there. Okay, if you're doing w equals 6y, and then w is a vector in your plane. Maybe bless God for not eating kosher. Oh, you want to say w equals, sure, 6y minus? Oh, 3y. Or wait, wouldn't we say 2z? Oh no. Wait, oh, this is w you're saying. Components. Wait, but that's just what we have here, is it not? Oh, we just have to change the limits then. Because we're not really... We want to say... The only tricky part is this y, I think. Right? Because... Oh, you want to say a vector in the plane. Basically just doing a rotation without rotating. Well, we are, yeah, that would be rotating it. But if we, wait. I feel like we can do it without that. Salami could be better, but everything tastes good at 2 a.m. Oh my gosh, it's 2 a.m. for you. It's like 4 p.m. here. 4:30. Oh my god, it's 4:30. Okay, let me think about this. Sorry, I feel like you guys have like suggested like 4 different ways to do this problem correctly, and I'm like, no, I want to do it the incorrect way more times. So like, let's say we had a random velocity, like let's say our velocity was going like this. It's not going like this, but... And we have the normal to the plane, and we want to figure out like how much is going through the plane, like in this direction. That's like essentially what we're trying to do. We're just trying to like project this onto this, which is just a dot product. So if I say this vector, so we have v dot, I'm just gonna call it a happy face, okay? A tired happy face. This is me at my limit. That's going to give us like the component of that in that direction. And then we have to say, okay, we slide it around. So we go from here to here, or whatever, I guess. This one is easy. That's 0 to 10. Happy face is bigger than X. But then when we get to here, it's like, okay, so... This is from... It's like a function of it though, is the thing. If we want to slide it from there to there, like what would that actually be? Let's see, it's a 3, 4, 5 triangle, so... Wait, is it? No, it's a 3, 6... So it'd be so that's the square root of 45. It's like 0 to 45, or square root of 45. Yeah, I mean, I guess if you... if you have to rotate it by the same amount, like the same degrees the plane is at though, right? And you have to rotate Vx as well. Man, my brain is not functioning correctly right now. What are we even finding? Oh, okay, we're trying to find the flow rate through this surface. So like, there's like water, you know, whatever. It doesn't look like that. It looks like this. Or we're trying to say like how much is flowing through this surface here. I mean, well, I might just have to call it. I really need to I just need to look back at these notes that I had, and I don't know where the notes are, and that's, oh god, there's a car tire scream. I think I'm gonna call it. I don't need to like do this for tomorrow or anything. I'm gonna be the velocity of the water. Not exactly. It's more like it's a little bit more in depth than that. It's like the velocity of the water and how much of the water is flowing through. It's like you can have water that goes faster, but like not a lot of water, and that's going to change the volume flow rate as well, right? Like if you think about, you know, turning on a hose just like a trickle versus like turning on a hose like a lot. The velocity and the amount of water coming out are different. So momentum, pretty much, or we do like conservation of momentum, conservation of mass, conservation of stuff to figure out volume, flow rates, and all that. But this is literally just saying like how much of your velocity field is going through a given area vector. That's all it is. So if your area, if there's more of your velocity going through an area vector, then it goes up. And if there's a faster velocity going through your area vector, it also goes up. I'm gonna figure this out, and I'm gonna explain it next time, and I'm gonna be rock solid on it, and it's gonna be beautiful, okay? Thank you guys for like sticking with me. This one, man, this professor just he's an immovable object. Truly. But it's good. It's a good problem, and it's like an easy problem, and it really shouldn't be this hard, but you know, just something like I need to get back into math, man. I haven't done math in a long time. Wish I could stream more. I will stream more before I'm done with it. I might do math minor though. Depends on how much time I have. Alright, well, I'll be around Sunday, probably, is the next time. And, I mean, we kind of finished. I mean, we did a lot of linear stuff. What did we do? We did all of this. I liked this one. This one was great. The Gaussian process of integration stuff. That one's easy. This one I didn't finish. I didn't do the piecewise one either. I have to make sure those constants are right, and then this is also a constant one. Ow, I missed it? Oh, it's okay. I have a VODs channel. It's linked in my description. If you, it's not gonna be, this one is not gonna be uploaded soon because I have to get through my backlog, but if you do want to see other math that I did a lot more math back in the day when I took more math classes, so, yeah, you can always check that out. Or you can just, I keep my VODs up, so if you really want to watch it, then that'd be swag. I am gonna call it quits. Hope everybody has a really nice day. Oh, thank you for the follow, by the way. It's awesome. Ain't Begula. Ain't Begula? Names. Can't read them, ever. Goodbye, goodbye. Alright. See y'all. Have a great day.